Hello and welcome back to part 2 of step 13. So in this video, we're going to use what we did in part 1, which is writing the ratios, but this time we're actually going to start solving for other lengths of the triangle. So we would know an angle, we know a side, but we're missing a side that we want to find. Okay, so in our number 1, you're also going to need a calculator. So if you don't have a calculator out, pause your video real quick so that you can grab a calculator. All right, so hopefully we're using our nice little acronym for ourselves. I'm going to write that right here so we remember it. So SOHCAHTOA. Okay, so number 1, remember we're always taking the sine, cosine, and tangent of that acute angle. So for number 1, we're going to focus on 25. For number 2, we're going to focus on 70, right? We're not going to take the sine, the cosine, or tangent of the 90. So if we're looking at 25, right, we have 2 of our 3 side lengths, okay? So hopefully you're thinking, well, x, right, is all the way across the triangle. So this is the opposite side. 18 is right next to the 25, so it has the option to be adjacent or hypotenuse, okay? It's going to be the adjacent side because it is not the longest in the triangle. It's not opposite the 90-degree angle, okay? So based on the information we have an acute angle, which is good. We know we have an adjacent side and we have an opposite side. So as long as we are still able to label the triangle correctly, we now have to decide how to pick the trig ratio we're going to use. Are we going to use sine? Are we going to use cosine? Are we going to use tangent? So this is when that acronym really comes into play. So if we have adjacent and opposite, we're going to look for the one that has an A and an O. So not sine, not cosine, and not tangent. So when we take tangent of our angle, we would use both of the sides we have information about. So the opposite side would be x, and the adjacent side would be 18. Okay, so then from here, right, in the last video, we had an unknown of our angle, but we were just practicing writing the ratios. This time, we actually need to solve for x. Okay, so what we're going to do is we're going to think, okay, what is the 18 doing for the x? Just like in any regular old equation. And hopefully you're thinking it says x divided by 18. So we're going to multiply both sides by 18. Okay, on the right hand side, the 18s would cancel. On the left hand side, this 18 does not get to go inside of the tangent. It's going to stay as just 18 times the tangent of 25. Okay, nothing else we can do there. So then from here, you're probably thinking, well, Mrs. Duncan, I don't know what the tangent of 25 is. How are we going to figure that out? And that's where the calculator comes into play. Okay, so on your calculator, there's one thing that I want you to check real quick before we plug this in. Right next to the second button is this mode button. So when you pull that up, you might have accidentally pulled this up and not realized what all this is. This is basically kind of like the settings of the calculator. You know, how many decimal places we have, which function we're using, all kinds of stuff. So your calculator, in order to calculate this correctly, has to be in degree mode. Notice my calculator, if we go 2 down, radians is in dark black with white writing. So my calculator is currently in radians. So I need to switch it so that it's in degree. So I'm going to arrow down and arrow over so that it's flashing on degree, and I'm going to hit enter. Notice now degree is dark in the background and white, and I know my calculator is in degree mode. If your calculator is in degree mode already, no need to change anything. Just wanted to make sure we're all on the same page so that we're not getting the incorrect answer there. Okay, so then we're going to type in exactly what our problem says, 18 times, and then your sine, cosine, and tangent buttons are right here in the middle. Okay, so we're going to hit tangent of 25, and we're going to hit enter. Okay, the question, if you didn't catch it, said round to the nearest hundredth. So we're going to round to 2 decimal places. Okay, so 8.3. This 3 would tell the 9 to stay a 9. So it's going to stay. Oopsies. Okay, there we go. So we're going to get x is 8.39 would be our answer. Okay, which definitely makes sense because if we're going to a smaller side opposite the smallest angle, our number should have gotten smaller. So that's good. All right, let's do the next one. We might go a little faster on this one. So we're looking at 70, okay? X is going to be our hypotenuse because it's opposite the right angle. 15 is right next to the 70, but it's not the hypotenuse. So this is going to be adjacent. So we're looking for H and A, which would lead us to cosine. So we're going to take the cosine of our angle, which is 70, equals 15 over x. Okay, so this time, notice we wrote a similar ratio, but it's just slightly different, right? Our x is on the bottom. So what you want to do always when you're solving for a segment length is you always want to start by multiplying to get rid of this fraction. So let's multiply both sides by x. Okay, so we get x times the cosine of 70. Remember that x cannot go inside of the cosine, it just stays outside. The x's on the right will cancel. Okay, so now we have x out of the denominator, which is great. That's definitely what we want. Okay, but now we have to get rid of this cosine. So the cosine and the x are being multiplied together. So we're going to divide both sides by the cosine of 70. Okay, so x is going to be 15 over the cosine of 70. Okay, then we're going to resort back to our calculator. So you have a couple different ways you can type this into your calculator. You can just do a regular old division problem. Excuse me. And type it in just like that. Okay, if you are one that likes the fractions because we saw it as a fraction, right? We can always do our alpha y equals and do 15 over the cosine of 70. And we get the same thing, okay? Remember, we're rounding to the nearest hundredth, so this 5 is going to become a 6 because of the 7. So 43.86 would be our answer. Okay. Let's look at one more real quick. I just want to show you how, depending on our location, we could use different ratios. Okay, so we have a hiker and the trail slopes up about 5 degrees and horizontally at 100. We're looking for x and y here. Okay, so maybe we'll get this question started and then I'll let you finish it yourself so you can have some practice, okay? So we can focus on the 5, right? That's our acute angle, okay? Y is across from our 90, so that's going to be our opposite. X is all the way across the triangle, so that's going to be, oh my gosh, I don't know why I said opposite, sorry. That should be our hypotenuse there at Y. X would be our opposite, and 100 is right next to, but not the hypotenuse, so that's going to be our adjacent. Okay, so if we started out by finding X, okay, we would have the opposite, right? X is opposite, and 100 is our adjacent. So if we wrote it out real quick, so Katoa, opposite and adjacent would tell us to do tangent of 5 is x over 100. Okay, then when we find x, okay, I'll let you pause the video and try it. Our x ends up being 8.75 feet. Okay, but then we still have to find y. So you kind of have some options here because at this point, now you have x. Okay, so if you have x, then you could use the opposite or you could use the adjacent. I like to use the values that are not rounded, so I would probably stick with the adjacent side again and use my cosine. But either way, you're going to get a very similar answer and be able to solve. Okay, so why don't you pause the video, and if you haven't already, finish this tangent one here. And then this one ends up being 100.38 feet. So why don't you go ahead, pause those, and make sure you get the right answer. But thanks for watching.